Good afternoon, colleagues. Today's presentation is about the Part 1 marking guideline mediation. Please, colleagues, you are humbly requested to note all the things that will be discussed here. And it's also very important that if you have any clarity-seeking question, please, you have the platform to ask. But in case you watch this presentation after it was broadcasted live, then you still have my numbers to make sure that you ask. But what is important is to make sure that we mark these learners according to what has been indicated in the marking guideline and as per the discussion that will be presented here. Please make sure that you don't mark anything that you do not understand. In case learners present certain solutions that are not discussed here or anything that you feel you are not comfortable in terms of marking it, you have my numbers. Please make sure that you contact me so that we can engage and see how best we provide the best feedback to our learners. The whole exercise is to make sure that we give learners the marks that they deserve, not disadvantage them, and also not advantaging them where they are not supposed to be. Please make sure that you follow it, and you follow it religiously so. And make sure that you mark, and then you mark according to the marking guideline as discussed. Any question, please, they are welcome to please make sure that you ask so that we can make sure that we address any areas of uncertainty in terms of the marking guideline. Now, colleagues, as you are all aware, our learners wrote the PET for the first time in technical maths, and we have PET 1, and this will be the exercise even moving forward in PET 2 as well as PET 3. Now, colleagues, on PET 1, when you look at question 1, the question one was saying classify each complex number by placing a value in the appropriate column. I know if you look at the marking guideline, I know you have this marking guideline. The marking indicated in the marking guideline are not correct. Remember in the question paper, this was 3 marks. Now the first mark will be all the correct values in the first question, that is number 1. Remember the complex number was 5 plus 2i. Now you identify first the imaginary number, then you identify the real number, and then lastly, you put in the complex conjugate. Now, 5 plus 2i, as you can see, the imaginary number now becomes 2i. And the real number becomes 5. Therefore, we also have the conjugate of the complex number, which is 5 plus 2i. It becomes 5 minus 2i. So a learner will be given a mark if all 3 are correct. Colleagues, let me repeat. If all 3 are correct, then a learner will be given a mark. Now, if any of the 3 is not correct, therefore that implies that a learner will get 0. All 3 must be correct. That is 2i plus 5. 5 minus 2i. This is the only solution, and therefore the learner will be allocated 1 mark if all 3 are correct. And if any of them is not correct, therefore a learner will be penalized. You look at number 2, the complex number is -8 plus half of I. Then you check the imaginary number is half I. The real number is -8, and the conjugate of this complex number becomes -8 minus 1 over 2i. If 3 of them, like it is the case with number 1, are correct, then a learner will get a mark. The last one, -3i. Colleagues, let us not forget -3i is the same as 0 minus 3i. Because -3i is 0 minus 3i, then it implies that the real number now becomes 0. This is where 0 comes from. And the imaginary number becomes negative 3i. And the complex conjugate of negative 3i will be 3i. Colleagues, please, you are urged to please look at all the values. Pay special attention to each and every value here. Because if any of them is incorrect, then a learner is penalized. You must check all the values. When you say all the values, it implies that even the sign of the value indicated there. And therefore, question 1 will be 3 marks. As we continue, colleagues, in question number 2, when you look at question number 2, the question was, determine with the aid of an argand diagram the sum of Z1, and Z1 in this case is negative 8 plus 3i, and Z2 is equals to 3 minus 5i. So what are we calculating here? We are calculating the sum. So when you look at the sum, first you need to calculate the sum of Z1 and Z2. And then after, the sum of Z1 and Z2 must be indicated in the argand diagram together with Z1 as well as Z2. Now, colleagues, if you look at this question, it says negative 8 plus 3i. The solution to the question is negative 8 plus 3i plus 3 minus 5i. Negative 8 plus 3 will give us negative 5, and 3i minus 5i will give us negative 2i. Therefore, the only solution acceptable in this question will be negative 5 minus 2i in terms of the sum. Colleagues, you accept negative 5 minus 2i as the solution, and this is a mark. And thereafter, learners are expected to represent the solution in the argand diagram. What do they represent? They represent Z1, they represent Z2, and they also represent the sum of the two, which is negative 5 minus 2i. So the first mark will go for negative 5 minus 2i, 1 mark. The second mark will be plotting of Z1. Remember, Z1 is given, which is negative 8 plus 3i. For plotting Z1 as well as Z2, colleagues, the second mark goes for the plotting of both Z1 as well as what? As Z2. Z1 and Z2, 1 mark. Both of them is 1 mark. So this 1 mark is for both Z1 and Z2. And then the last mark will be plotting of the sum, which is the resultant. And the resultant in this case is negative 5 minus 2i, then it will be a mark. But colleagues, please take note. There will be instances where learners will correctly write Z1 plus Z2, but their sum is not correct. Therefore, that learner is penalized for incorrect sum. But for the graph of Z1, for plotting Z1 and Z2, considering they are given, they should be accurate. But in a case that the sum is not correct, colleagues, please, you are kindly requested to follow what the learners wrote. In case the sum is not correct here, check the sum that the learners indicated. And if it is correctly plotted here, you must allocate a mark. You must allocate a mark. I repeat, colleagues, the sum in case the learner wrote incorrect sum. Then plotting of the resultant, which is the plotting of the sum of Z1 and Z2, will depend on the learner's solution here. For argument's sake, if the learner says this is 5 minus 2i, and if the learner plotted 5 minus 2i correctly, therefore that learner must be allocated a mark because the plotting is correct in relation to an incorrect sum. In simple terms, it becomes a CA mark. But Z1 and Z2 must be allocated a mark as an accuracy mark, considering Z1 and Z2 are given. And that will be 3 marks. As you continue with 2.1.2, now remember that 2.1.1 says the sum. And now 2.1.2 requires learners to determine the difference between the two. Therefore, you have Z3. In this case, it is Z3 and Z4, and they are given. Where Z3 is given as 9 minus 7i, and Z4 is given as 6 plus I. Therefore, as you substitute, you'll have 9 minus 7i minus into 6 plus I. And then the difference will be 3 minus 8i. So a learner will be allocated a mark for 3 minus 8i for the difference of the two. And in simple terms, this can be an accuracy mark. You can't expect any answer except 3 minus 8i. Now remember the question says, find the difference and you plot. And as you plot, like it is the case with 2.1.1, Z3 as well as Z4 are given. Because they are given, then the plotting of the two must be accurate. Therefore, you have plotting of Z3 and Z4. Plotting of Z3 and Z4 will be 1 mark. This is for both Z3 as well as Z4. There will be a mark. And the last mark will be the plotting of the resultant. And the resultant in this case, it is 3 minus 8i. Now, again, colleagues, let's say, for instance, you have Z3 minus Z4. Learners correctly substitute. But remember, mark is not allocated for substitution. The mark is only allocated for the difference, which is the answer. But let's say the learner's response here is incorrect. You'll find instances where learners will write 9 minus 7i minus 6 plus I, omitting multiplying by negative, negative by positive I. Therefore, the solution will not be the same as in the marking guideline. So in simple terms, if a learner presents an answer not the same as this one, then you need to follow it. Let's say the solution from the learner is 3 plus 8i. Therefore, the plotting will represent what the learner wrote. Therefore, the plotting of the resultant will depend on the learner solution in 2.1.2 first step. Therefore, this will therefore become your continuous accuracy mark. Colleagues, please take note. Z3 and Z4, they must be accurate because this is a given information. But in terms of the difference, you look at the learner's response. And if the learner's response is not the same as this one, therefore, the plotting will be the same as what the learner got in terms of the difference. So you need to follow what the learner wrote in 2.1.1 as well as 2.1.2. And then, colleagues, as you move on 2.2.1, in 2.2.1, the question statement says, sketch the given complex number and its complex conjugate on the grid provided. Now you are given Z3 as 9 minus 7i. This is Z3, which is 9 minus 7i. It's a given information. The question requires its conjugate. And the conjugate of Z3 will be 9 plus 7i. Therefore, this must be an accuracy mark. A learner will get a mark for saying 9 plus 7i. Now, this is the first mark for conjugate. And the second mark will be plotting what is given. Remember, learners in this case are given that Z3 is equals to 9 minus 7i. Plotting this, the Z3 which is given should be an accuracy mark because it comes from the given information. And then the plotting of its conjugate. Therefore, plotting of its conjugate will also have 1 mark. But if the learner did not get the correct conjugate, it means you mark the plotting in relation to an incorrect conjugate indicated by the learner. Therefore, the learner will be penalized for incorrect conjugate. But if that incorrect conjugate is plotted correctly here, the learner will be allocated a mark, which will therefore mean a learner will get 2 marks in a case that Z3 plotting is correct and incorrect conjugate is correctly plotted. Therefore, that learner will get 2 out of 3. And then that will be 3 marks in question 2.2.1. And then, colleagues, looking at 2.2.2, you have now Z4, which is equals to 6 plus I. The same question here. What do you do in Z4? You write its conjugate. And the conjugate of Z4, which is 6 plus I, becomes 6 minus I. Therefore, this will be, it is not allocated a mark here. This one, please take note. A mark for conjugate is only allocated in 2.2.1. But in 2.2.2, the mark for conjugate is not allocated. What is allocated here is the plotting of Z4 and its conjugate. Remember, Z4 is given. Therefore, Z4 is given as 6 plus I. The plotting of Z4 should be an accuracy mark. Now, the plotting of a conjugate of Z4, which is 6 minus I, now becomes this one, which will be the plotting, it's a mark. But now look at this one, colleagues. Remember, there is no mark allocated for the conjugate of Z4. When do we see A? We see A when a learner is penalized in the first step. But what is wrong in the first step is correctly executed in the next step, then it's CA. But in this case, the conjugate is not allocated a mark. Therefore, the plotting of its conjugate must also be accurate. Because you can't say continuous accuracy when in the previous step there was no mark allocated in it. Therefore, in the 2, the first Z4, plotting is a mark. And its conjugate plotting must also be accurate, and then it is also a mark. Therefore, a learner will get how many marks? 2 marks. And colleagues, as you move on, 2.3. 2.3 says, what can you deduce from question 2.2.1 and 2.2.2 about the complex number and its complex conjugate, which is 1 mark. This is only 1 mark for deduction, and the only solution expected is the complex conjugate is a reflection of its complex number about the real axis. What is key here? It is a reflection about the real axis. Colleagues, take note. It's a reflection about the real axis. That will be your deduction. The key word here, a reflection about what? About the real axis. And it will be 1 mark. The other thing is the complex conjugate is symmetrical to its complex number about the real axis. So you accept either the first explanation or the second one. It depends what the learner wrote. But these are the only solutions in 2.3. And therefore, question 2 will be 12 marks. And colleagues, I hope you are following as you continue in question 3. Question 3 It's about the polar form and graphical representation of complex numbers. Now the first one, it says, convert to polar form and represent on an Argand diagram the following rectangular complex numbers. And 3.1, you are given Z equals to 4I. Like I indicated when you were identifying the complex numbers in question 1. Remember what I said in number 3, that negative 3I is the same as 0 minus 3I. Therefore, if you look at the very first question, it says Z is equals to 4I, which in essence implies that you have 0 plus 4I. Now the first mark will be for modulus. R is equals to 4. That will be the first mark, 1 mark. And then the second mark, and it must be an accuracy mark. And the second mark will be your angle 90 degrees. Remember, in technical mathematics, we work with radiant measures a lot. Therefore, you'll find learners not writing 90 degrees, but writing their angle in radians, which will be pi over 2. Accept 90 degrees or pi over 2, and then that will be your mark. Maybe the question will be, where do we get it? Remember, you have 0 plus 4I. And therefore, if you are to find the angle here, you will have 4 divided by 0, which will give us an undefined value. It means that is asymptotic to the 90 degrees, about the line 90 degrees. Therefore, that is why we have the angle 90 degrees here. And therefore, you get a mark here, and the second mark will be writing it in polar form. But now the question is, which polar form is indicated here? You are given the polar form, 4 is 90. You also have 4 cos 90 plus I 90 degrees. Remember, you also have, because there is no specific polar form indicated here, you can also have the polar form for 90 degrees. Accept all of them. Please take note, even this one is one of the solutions. You have this one indicated in the marking guideline. You have this one, and the marking guideline omitted this other part, which is for 90 degrees. Please accept this one because it's also another polar form. Therefore, you get a mark like I indicated for the value of R, 2 for the angle, whether in degrees or in radian form, and also polar form. And the last mark, please, like I indicated, accept any of the polar forms indicated here. And therefore, even this one can be written as 4 pi over 2, which can also be accepted. It can either be this one or this one, because 90 degrees can also be represented as pi over 2. And then the last mark will be the correct plotting, which will be on the imaginary axis. Which will be on the imaginary axis. You give a mark there. And then the learner will get how many marks? 4 marks for this one. And as we continue, colleagues, with 3.2, looking at 3.2, what do we have in 3.2? The question says, you find it is still the same question as 3.1, which says, convert to polar form and represent on an Argand diagram the following rectangular complex numbers. You look at 3.2, the question that we have here is Z is equals to 2 square root of 5 plus 2I. Now the first mark will be for substitution. The first mark will be for substitution. And remember, substitution is from the complex number given, which will therefore be 2 square root of 5 squared plus 2 squared. Substitution. And then the next mark will be for the value of R. Please, colleagues, if the learner leave the answer as R is equals to square root of 24, that can still be, that is still correct. because it never says in simplified set form. So if it is square root of 24, you accept it. If the learner writes it as 2 square root of 6, it's still okay. So don't penalize the learner if you don't see 2 square root of c. Even if you see square root of 24, give a mark for that. So that will be the value of r. And then the next mark will be the tan ratio, which is 2 divided by 2 square root of 5. Therefore, the learner already has how many marks? 3 marks. Colleagues, the next mark will be for the angle, which is 24.09. And then you'll find learners reducing, finding another quadrant where tangent is positive. They are likely to go to the third quadrant. But when you look at the diagram, it's already in the first quadrant. Therefore, you can't find it in any other quadrant except the first quadrant. Therefore, the only angle acceptable here is 24.09 based on the diagram. Based on what you have here, the information here indicates that the imaginary part is in the first quadrant, positive, and the real part is also positive, which is the first quadrant. Therefore, the solution is only in the first quadrant. Therefore, like I indicated, 1 mark for substitution, 1 mark for the value of r, 1 mark for the tan ratio, and the next mark will be for the angle. Remember, the question says write it in polar form, and then the last mark will be for the polar form. And the polar form can be this way, the polar form can be this way, or the polar form can also be 2 square root of 6, and then you put an angle there, which is 24.09 degrees. Accept any from this step in the polar form. And then the last mark will be for plotting. Colleagues, let's go back. The first mark, substitution. The second mark, the value of r. The third mark is the ratio. But in a case, the ratio of a tan is incorrect, therefore the learner will not get the same answer as this one. Let's say the value of r is also incorrect. If the value of r is incorrect, it doesn't have any effect on the tan ratio. But if the learner writes, let's say for instance, instead of writing 2 over 2 square root of 5, the learner writes 2 square root of 5 over 2. Swap the values, numerator and the denominators. Therefore, the angle will not be the same as indicated here. You must follow what the learner wrote. If the tan ratio is incorrect, the learner is penalized. But the angle is correct according to the incorrect tan ratio. This must be a continuous accuracy mark. And obviously this one will also be a continuous accuracy mark. And surely the diagram will depend on what the learner wrote here as the solution. Therefore the marks are, the diagram must be correct, considering that the z is given where it's indicated that you have 2 square root of 5, and 2 square root of 5 is the real part, is in the first quadrant. And again, imaginary number is 2i, which is positive, is in the first quadrant. Therefore, your diagram must be in the first quadrant. You only accept the plotting if it is in the first quadrant. You can be lenient in terms of the angle not correct, in terms of the value of r not correct, but the diagram must be in the first quadrant based on the given information. Colleagues, I repeat, substitution, the value of r, tan ratio, and in case the tan ratio is incorrect, follow what the learner wrote here. It means you must press a calculator and check if the learner given, if the angle given by the learner here is correct in relation to the tan ratio, which is incorrect that they indicated here. So the learner will be penalized here, but the angle will be correct based on an incorrect tan ratio. Therefore, it becomes a CA mark. And then the polar form will be a CA mark. But remember, I said, colleagues, the plotting must only be in the first quadrant, because the information given indicates that the diagram is in the first quadrant. And therefore, you can be lenient in terms of the angles, but as long as the plotting is in the first quadrant, you can allocate a mark for a learner there. And therefore, that will be 6 marks. And question 3, all in all, it will be 10 marks. And as we continue, colleagues, moving on to question 4. Question 4, which happens to be, it is not the last. Question 4, I thought it's the last. Use a protractor, measure angles, theta and beta. Now, learners have to measure here, colleagues. The first angle measure is 45 degrees. The second angle measure is 135 degrees. Please, colleagues, as learners measure, there's a likelihood that they will not get exactly 45 degrees. They will not get exactly 135 degrees based on what they got here. Check the learner's measurements, and we can agree. We can agree on an angle ranging to 45. Let's say, for instance, ranging from 43 degrees and to, say, 47. It must be a reasonable measure. But imagine a learner indicating a measure that is saying 120. When you can see it can't be 120. It's an acute angle. Therefore, an angle indicated there, please let's accept any angle measured by a learner from 43 to 47 degrees. And obviously, when you look at beta, it has 45 has an influence on it. Therefore, check in relation to this angle. And therefore, you need to see a mark, learners. So, colleagues, please make sure that when you have this angle of 45 degrees, and the learner gets something else, not 45, but it must be a reasonable measure. As I said, from 43 to 47, it can be an acceptable range. And therefore, this will be influenced by what the learner measured here. And the learner will get a theta as well as beta. Please, colleagues, make sure that you follow what the learners indicated here. But it must be a reasonable measure. You can't have theta being an obtuse when you can see it an acute angle, and beta being an acute when you can see it an obtuse angle. Please check what the learners measured today as you mark. And then 4.2, it says write Z1 and Z2 in polar form. Now we have Z1 as 4 plus 4i. In polar form, you have Z1. Where do we have Z1? We have Z1, yes. The information in the question, it says Z1 is 4 square root of 2 cis theta, and Z2 is 6 square root of 2 cis beta. Therefore, as you write the two, Z1 and Z2 in polar form, you have Z1 to be 4 plus 4i, and Z2 to be negative 3 plus what? Plus 3i. These are the only accepted solutions in this question. Therefore, you'll have the two solutions. And then in 4.3, determine the resultant force, ZR, if Z1 plus Z2 is the sum. So that simply implies we add the two. We add the two. As you add the two, you get 1 plus 7i. And this is the only solution, and it will be 1 mark. And then Z 4.4, it says now express Z3 in polar form. As you expressed Z3 in polar form, this is your Z3, and the only acceptable answer here is 5 square root of 2 cis h 1.87 degrees, and that will be allocated 1 mark, which will also be an accuracy mark. And then lastly, colleagues, under question 4, we have 4.5, which says represent the resultant force in an Argand diagram. Now remember, colleagues, you have Z1, you have Z2, and you have to now also plot Z1, Z2 as well as the resultant force. So 1 mark will be for Z1, which is a given information, Z2, a given information. Therefore, these two must be accuracy marks. But Z3 will depend on the sum that learners will get on Z1 plus Z2 in 4.3. Therefore, you need to follow on the solution that the learner got in 4.3. Whatever the learner got here, if it is not 1 plus 7i, you must follow it. And if it is correctly plotted here, you allocate a mark. And that will be 3. And therefore, 4.5 will be allocated 3 marks. And the total for question 4 will be 9 marks. And lastly, colleagues, question 5. Question 5 is about application of complex numbers in electronics, RLC circuits. Now, it says determine the total impedance ZT equals to Z1 multiplied by Z2 all over Z1 plus Z2. Now, it's a question of substitution here because the magnitudes of Z1, Z2 are given, where Z1 is given as 30 plus 10i and Z2 is given as 10 minus 30i. So when you substitute, you have 30 plus 10i multiplied by 10 minus 30i, and Z1 you substitute, and Z2 you substitute. Therefore, 1 mark for substitution of Z1 and Z2 in the given total impedance. Now from there, you give a mark for simplification. What is this simplification? Simplification, it means multiplying the numerator, as well as multiplying what? The denominator, you give a mark. And then the third mark will be indicating that I squared is equals to -1. And then the fourth mark will be multiplying by a conjugate of the denominator. Remember, after you simplify here, you are left with 600 minus 800i divided by 40 minus 20i. And the conjugate of 40 minus 20i becomes 40 plus 20i divided by 40 plus 20i. So multiplying by its conjugate, the conjugate of the simplified form will be a mark. And then the next mark, after multiplying by conjugate, you multiply numerator with numerator, denominator with denominator, you get the simplified form. Therefore, the simplification is also a mark. And lastly, the last mark will be given for 20 minus 10i, and it will be 6 marks. Colleagues, please take note. Let's say, for instance, 1 mark. Remember, we said first mark is for substitution. And let's say learner substituted incorrectly. Therefore, that learner is penalized here. But the simplification is correct based on an incorrect substitution. Then you see A moving forward. The same applies if substitution is correct, simplification is incorrect, but the follow-up steps are correct. After an incorrect simplification, please, colleagues, you need to see A. Therefore, the only mark that is accurate is for substitution. All other marks you need to follow on what learners wrote. And that will be 6 marks, and the total of your Pet 1 will be 40 marks. Colleagues, please make sure that you follow the marking guideline. In case you have questions, in case you need some clarity on certain issues, please make sure that you contact me so that we can clarify, we discuss. Thank you very much. And colleagues, lastly, before we close, we are done with the PET, but I need us to talk about the common test that I propose that you write, you administer it next week. That will be Tuesday, next week. Colleagues, on the common test, remember, not all schools completed what is in their page set. Now, I suggested or I proposed that we have the common test such that we assess on integration. Integration where? Definite integrals as well as indefinite integrals. Of course, we need to start with indefinite and then the definite. And then the definite integrals, I'm sure, colleagues, you are aware, we are talking about the area between the curve and the x-axis, whether it is above the x-axis or below the x-axis. That is the area between the curve and the x-axis, which is the definite integrals. So your paper will be on integration as well as trigonometry. But in terms of integration, everything will be assessed, definite as well as indefinite integrals. And under integration, colleagues, the total will be 14 marks. I repeat, I'm giving you the exact marks allocated in the paper. 14 on indefinite integrals as well as definite integrals. And then the last part will be on trigonometry. What we need to do with our learners or revise with our learners in preparation to the common test. Remember, we have questions where learners are given the magnitude of the angles and they are given the trig ratios, where they substitute, use a calculator to find the value of the trig ratio given. That is the first part. The second part will be on where learners are given the question, say for instance, 2 sine theta, 5 sine theta minus 3 is equals to 0, where they find the trig ratio and represent that trig ratio in a Cartesian plane. And therefore, they use a diagram without the use of a calculator to find the trig ratios. Calculator, diagram without the use of a calculator, and then they also have to know how to do trigonometric equations, simple trigonometric equations. Colleagues, I'm sure you know what I'm talking about. Simple trigonometric equations where learners have to solve for x, theta, and so forth, where they are given the parameters. Theta is an element of 0 to 360, an element of 0 to 180, 270, and so forth. But please take note, the parameters or the restriction can also be given in radians. Not only in degrees, but it can also be given in radians. And the other part will be on reductions. Colleagues, reductions. And remember, as you do reductions, we do only 180 degrees, plus or minus, as well as 360 degrees, plus or minus. Please, colleagues, don't do 90 degrees plus or minus. Don't do 270 degrees plus or minus, as it is not prescribed in the policy. I repeat, reductions 180 plus or minus, 180 plus or minus, as well as 360 plus or minus. No 90, no 270. Reductions, very important. As well as trigonometric identities. You know trigonometric identities, colleagues. Please take your learners through the trigonometric identities. Take them through the reductions. Take them through trigonometry where calculator is used. Take them through trigonometry where they find the trig ratio measures using the diagram without the use of a calculator, as well as trigonometric equations, simple trigonometric equations. I'm saying simple trigonometric equations because it is indicated like that even in the policy document. And then the next part will be trigonometric functions. Colleagues, remember on trigonometric functions, there are two things that we need to take note of. One, sketching of a trigonometric function. And after sketching of the trigonometric function, what is expected is the interpretation of it. What is the range? What is the domain? What is the amplitude? The areas where the other graph is above the next, above the other, where the other is below the other, where the product of the two functions will give a negative value, less than 0, where the product of the two functions will give us a positive value. That is where the two graphs, when they are multiplied, they give you negative answer, that is less than 0. It means where the other graph is above the x-axis and the other is below the x-axis. And therefore, where the product of the two functions is greater than 0, it implies that that is where both graphs are above the x-axis or both of them are below the x-axis. Please take note of those things, colleagues. And then the other thing very important is where the graph is increasing and where it is decreasing. I'm raising this one because more often than not in trigonometry, you find instances where you are given f at x is equals to 2 cos x. And the question says find the value or values of x where f prime x is greater than 0. And learners get confused to think they need to differentiate a trigonometric equation, trigonometric ratio, which is not necessarily true. We need to go back to calculus because this is an integration in trigonometry. We are integrating, what do we integrate? We are integrating calculus in trigonometric functions. That simply implies the question is actually asking where the gradient of that curve is positive, or in simple terms, where that function is increasing, not necessarily to differentiate. And all in all, when you look at trigonometry, colleagues, it will be 9 plus 13, which will give us 22, and that will be your 22 plus 14. It will give us 36. And all in all, your common test will be out of 50 marks. Colleagues, please, your common test will be administered next week on Thursday. 50 marks. What are we going to assess? Integration, trigonometry. But trigonometry up to trigonometric graphs. Why? Because we have taken into consideration when we are taking stock in terms of curriculum coverage, some colleagues have not covered certain aspects in the pace setter. Therefore, we are safe to say our learners are ready in terms of integration, they are ready in terms of trigonometry, where up to trigonometric graphs. So the expectation is moving forward when we have to administer other tests, we'll include 2Ds, 3Ds, we'll include also Euclid geometry so that our learners are ready for the trial examinations. Colleagues, please, if there are any challenges in terms of administering the common text, please make sure that you contact me so that you can see how best we close those gaps. Colleagues, wish you everything of the best and wish all your learners everything of the best. Please make sure that we encourage them to practice and make sure that we improve our results of technical maths. Thank you very much.